The following content is for entertainment and educational purposes only. It does not constitute means for diagnosis, healthcare advice, nor treatment. Make use of a qualified healthcare professional for such purposes.
Good afternoon, everyone. My name is Dr. Charlene Ortiz, and today we're going to begin a lecture. And this lecture is going to involve the analysis and interpretation of data. More specifically, however, it's simply the exposition of that data. How is it that we present information? There's many goals as to why it is important to present information that we have gathered in research in a very succinct and in a very clear fashion. So we do have tools that allow us to present our information that we have gathered through research. So let's get started. Now, one of the first things that I would like to cover is why exactly do we have to summarize data? Why is it that I cannot just gather the data, right? So for example, in your previous lab and your current lab, you have been looking into data. Why is it we can just present it? Well, there's multiple reasons. The first one, it allows that researcher or the consumers of research, for example, you guys in the future, remember that it's going to allow for that visual clarification, right? We can start seeing patterns in our data, right? So for example, if you have, let's say, a pie chart, you conduct one research study and it seems that that data split 50-50, notice that if next time that study is replicated or somebody else conducts a similar study and you start seeing the same thing, you start seeing the same pattern, right? Then it allows you to visually see that pattern and it clarifies that pattern for you. Another reason is that it allows us to be concise. The issue that we generally have when we are gathering data is that it usually looks very overwhelming. There's usually many items, there's usually many data sets, many data points. And generally, that is not the best presentation, first of all, because it's overwhelming. And second of all, it doesn't give us a summary. It doesn't allow us to view that data in a more specific fashion. Now, in order to provide that summary, in order for us to be succinct, we need to see and make sure that several things occur. Before we conduct that summary, we must review that data. You want to ensure that you are reviewing it. You may say, well, how exactly do I review? The first thing that you would like to do is ascertain whether or not there's something that you might omitted, right? There's something you yourself omitted, whether it be by accident, or maybe some of your colleagues that were with you in that research omitted something maliciously and with a specific agenda in mind. So you want to make sure that you verify any sort of omission. Another issue, another way that you can review your data is by looking into errors in your data. I have to remind you, error is always going to be present in research. More so in those of social sciences, because generally we do have a less level of certainty, right? We usually use that alpha, right? That p-value of 0.05, I should say. Normally, it's kind of rare to see that 0.001, right? 0.99% sure that I'm certain. So there's always that room for error. Now, keep in mind, you do want to make sure that if there is a level of error, what did you do in your study to minimize it, right? Any other issues that you may come across. The good thing of identifying all of these issues early, omission, errors, other anomalies, is that you're able to remove all of these hiccups. You're able to remove all of these hiccups before you actually start analyzing that data. Before you start analyzing that data. Some of you might have heard the expression measure twice, cut once, right? That is the intent of revising our data. Before you actually start interpreting such information, we want to make sure that we measure twice, right? Like that's saying, we want to make sure that all those hiccups have been removed because that minimizes the chances of you committing a mistake during the interpretation, which is why we're here, right? We're conducting research to find out what did the data suggest? What is the interpretation? So any questions about that? Good deal. Fantastic. All right. Now, in the step that we're currently in, right? Notice that for the purposes of this class, we're going to assume, and for those of you watching at home, we're going to assume that you already conducted that study, right? You have gathered your data, you had that IRB approval, recruited participants, conducted your study. Now we're in the step in which we're going to conduct that review, right? We're going to conduct that exploration to identify all of these little hiccups. So this is a good illustration of where we are in that research process. So I like to think about right now as a young scholar, right? Think about what research would you like to do, right? Oh, I would like to do research on this. I want you to put yourself in that mindset because now we're going to see how is my data going to be presented. So that's the step that you guys are currently in right now. So think about that nice research that you wish you could do. Now, when we are analyzing data, when we are analyzing a data set, interestingly, one of the things that the term analyzing refers to, first of all, it involves a description, right? It involves a description. When we are conducting any sort of analysis for that matter, one of the first things to consider is how am I going to describe the information? Later, so this is going to be a little first step, and our second step is going to be that interpretation. So generally, we describe first, and then we interpret. We don't want to conduct that interpretation before we can describe that phenomena or that issue, right? Wouldn't be pretty scientifically sound with it. We don't want to draw conclusions before we can actually describe and understand that phenomena. How is it that we conduct this type of description? Easily enough, because we have descriptive statistics. Descriptive statistics. Now, descriptive statistics, their intent is to summarize data. So if you take nothing else from descriptive statistics, is that they summarize data in order to make sense, in order for us to make sense of the meaning of those measurements. I'm trying to describe what that measurement looked like. I'm trying to describe what the results were before we draw any conclusions, right? So if you take nothing else from descriptive statistics, is that it allows us to summarize data without drawing conclusions. You guys, I might have heard the example of don't shoot the messenger, right? That's what descriptive statistics are. They are that messenger. Hey, I'm just here to give you the information with no interpretation whatsoever. Okay? So this is the don't shoot the messenger. There are multiple measurements, there are multiple statistics that we can make use of as descriptive statistics. So for example, mean, median, mode, variance, and the standard deviation, SD. Any questions about that? Good deal. Fantastic. Let's talk about one of the more basic ways in which we can find description. That's through frequency, right? Frequency. Frequency, it's simply a value that it's basically a number that is going to tell me how many times something happened, how much of a score did we have, how much of a range did we have. Notice that it simply means quantity, right? Frequency. So for example, if I have 250 students and the frequency of those who go to office hours, let's say it's 100, notice that that frequency, that 100 number, it's simply giving me an amount. It's simply giving me a number. Why do we need frequency? Well, generally, a good way to display frequencies, a really good way to display frequencies is generally through tables and through graphs. So here is an example of a distribution. And interestingly, we just had an exam here for this class. These are not the real results for the test, right? This is just an example. Although I think you guys did pretty good. So I'm proud of my little chickadees. I'm proud of my chickadees. So notice that here we have the exam score, right? So we have an individual who scored 90, an individual who scored 59, and so on and so forth. Now notice that with a frequency table, and a frequency table is basically going to demonstrate us, and it's going to count for us. That's what a frequency table is. It's counting for us. So notice that in here we have the same scores, right? So we grab all of these scores here and we translated them into the exam scores. And now my frequency table is just going to give me a count. So for instance, 3 students scored 90 to 99, 5 students scored 80 to 89, so on and so forth. So notice that a frequency table is showing me a count, right, of how many, right, and how many students scored 90 to 99. And you can translate this basically to anything that we can physically count on. For example, how many students went to office hours? How many individuals have ODD, right? How many individuals have PTSD, right? So it's simply a count. It doesn't tell me anything else other than the amount of something, okay? Any questions about that? Good deal. Now, generally, I do want you to take away that frequency is generally represented f of x. Okay, so I do want you to remember that. Generally, that's how we represent it. Generally, the type of data that we're going to illustrate in our frequency distribution table, it's either going to be continuous, discrete, or categorical. And if you need a quick reminder of the specifics of these variables, I'm going to link in the description a very detailed lecture that covers types of variables. If you want a very detailed explanation, you'll find it in the description. Now, interestingly, the type of data that we are utilizing, the type of data is going to tell us exactly how this data category is going to come about. For example, you have interval, right, versus an actual individual score. So based on the type of data, we're going to decide what type of data category we're going to show. So for instance, if I have, like in our previous example, we have a range, right? We decided to conduct a range, but say it was another form of data. Say, for example, it wasn't concrete, or it wasn't, it wasn't continuous, or it wasn't discrete. Notice that we would start then using other means instead of a frequency distribution table. And we do have other means to illustrate that, and more than likely, we're going to talk about them today. Any questions so far? Outstanding. Now, we were talking about tables, right? We're talking about tables. But like I said, we do have other means of measurement. So in this case, we can move into other aspects such as graphs. Talked about tables showing me that frequency, but I can also show you this information through a graph. So for most of you, Most of you are familiar with the X and Y axis, but I'm going to cover it very, very quickly. So generally, when we are looking into a graph, that was as straight as I could do it. I apologize. I tried my best, I promise. So generally, think about whenever you're drawing a graph, generally the point here when both axes meet 0, and then of course this would extend to infinity and infinity. The x-axis is the one that is horizontal, and the y-axis tends to be one that is vertical. And people get these really confused. And you know how I always remember which one's which? I always remember which one's which because why would I jump off a cliff? That's how I remember that's the vertical one, right? I'm sure you're never going to forget which one's the y-axis. It's like, why would you jump off a cliff? There you go. That's how I remember. You got to do what you got to do to remember things, folks, right? Now, generally in the types of graphs that we have multiple. For example, we have a histogram. And for discrete data, we're going to utilize either a bar chart or a pie chart. I'm going to give you examples of both of these. Let's move here. A little bigger. There you go. All right. So in this sense, when we are thinking about a histogram, generally when we have a histogram, we are working with specific type of data. For example, let's think about the information that we can have with that distribution of continuous data, but with a pie chart, we're probably moving towards a more discrete data. So think about when you have something that is continuous, something that could be seen along a continuum, whereas when we're thinking about something more discrete, think more about categories, right? So for example, if in the score in, let's say, a psychopathy exam, right? A psychopathy examination, we're looking at that range. So we could probably represent that through a histogram. Whereas if I'm talking about how many people are psychopathic, how many people are not, how many people show that personality trait in a mild fashion, now you're thinking more about categories, right? So that might be a little better represented with a bar chart or a pie chart. Any questions about that? Good deal. Good deal. Now, we talked about earlier that generally, when we are talking about the presentation of descriptive statistics, you're talking about things such as mean, frequency, right? It's just going to show me what the data looks like. It's just a messenger, right? It's not going to tell me more in-depth information. But one of the things that we can use, right, to summarize, as we mentioned, going to be the measures of central tendency. Measures of central tendency. When we are talking about measures of central tendency, these are statistical measures for locating a trend, right? Measures of central tendency, right? I want you to think about a trend, trying to identify and locate how is this trend, how near or far away it is from the center of that distribution, right? So I'll give you an example. So let's say that we're trying to find out, this is going to be my distribution, right? So Most of you, if not all of you, have seen a bell of normal distribution. For those of you who have not seen this, this image here simply illustrates, image here simply is going to illustrate all the amount of data that we would expect, right? So for example, in the middle, when something is normally distributed, we would assume that both everything, the median, the mode, all of these three factors are located right here. Now, our intent with the measures of central tendency, these three here, is to find out where does our data actually fall. Does our mean fall here? Does our median fall here? Does our mode fall here? And therefore, it's going to start being skewed towards one direction instead of looking symmetrical like this one. So notice that it doesn't tell me why it's skewed, but I can physically see if something is normally distributed, something is falling away from that center. So I can start noticing if something is moving more towards this direction, or if my data tends to move more towards this direction. That's why we use measures of central tendency. Now, let's talk about a little bit in detail about these measurements. So we have the mean, median, and the mode. Any questions about measures of central tendency before we continue? Basically, we're trying to locate, hey, where's my data compared to that distribution? How does it look like? Let's talk about the mean. The mean, it's basically what I like to refer to as the average, right? But as you know, if you're in my class, you're not average, so you don't fall here. But for you to be able to identify basic people, that's why you need to learn about the mean. The mean is basically that average, is the sum of all those scores, of all those data points, of all those data sets, and we're going to divide it by the number of those data sets. Simply put, say, for example, in your test, if a child's test of ODD, we conduct an assessment for ODD in a child, and then we're going to come up with some hypothetical numbers here. So say the score for the child, one child scored 50, the other child scored 40, the other child scored 38. Notice that I'm going to sum all of these scores, and this symbol here, whenever you see this M looking like symbol here, this means sum. Okay, so if you ever see that, I want you to remember that that symbol there represents sum. The adding of X. So if I have 50, 40, 38, I'm going to add all of these up, and then I'm going to divide it by the number that I had. So for example, I have one data set here, one data set here, one data set. So after I add all these numbers, how many data sets? 1, 2, 3. Therefore, divided by 3. That's pretty simple if I only have 3 data sets, right? But sometimes we can have 1,000, for example. But we'll talk about statistical packages later. Now, interestingly, when we are talking about the mean, we're trying to find out that balance point of that distribution, right? We're trying to find that balance point of the distribution, because not always that balance is going to be here, down the middle. That may not necessarily be the case. So think about, I'll give you a real life example. A lot of people like using salary because it's really easy to understand, but let's give you something a little bit more real world, which is what I tried to do here in class. Think about the normal distribution of all the American citizens, right? There's about 360 million American people, give or take, with the territories and all that. So about 350, I believe, something like that. This is what the 350 American people, for example, did. If they were normally distributed, let's assume that this is a score of psychopathy, right? This is a score of psychopathy, or let's think about, let's do a better one. Let's think about the population in a prison, right? So when we have antisocial behavior, generally, what that means is that we have a tendency to disregard authority, a tendency to show, especially with psychopathy, we're trying to, the capacity of being empathetic is diminished. So in a normally distributed population, right? Say, for example, the population in this town, if it's normally distributed, it's going to look like this. But if I go to a specific population, for example, an inmate population, my data can be skewed. So notice that from being average, or being down the middle, maybe my data is going to move further away from that central tendency, right? We start moving a little further away because the scores may be too high, or vice versa. Maybe we address a population that has lesser scores, but now we're going to start moving towards this direction. So notice that now my line is not down the middle. Now it's being skewed. It's either moving towards the negative or towards the positive. So the mean only tells me where it's placed, but it won't tell me why it's placed it. But it's a good visual representation to see, okay, my data is skewed somehow. Why is that? So any questions about the mean? Good deal. Good deal. Now, when it comes to the mean, you can only utilize interval or ratio scales. Let's talk about the median. Let's talk about the median. The median, as I explained, is also a measure of central tendency. And the median is basically that middle value, in that distribution whenever I put every single data set in order. So let's think about the same example that I was giving you about, say, we're assessing psychopathy. Right? And when we were assessing psychopathy, we had a person scored 22. We have an individual who scored 18. We have an individual who scored, say, 15. We have an individual here who scored 31. So the median is going to be that midpoint in the distribution. So the first thing that I would do is put these in order, right? And add some other guy here. Let's do that. 17. So what the first thing I would need to do is put them in order to calculate that median, right? So my lowest value is 15, followed by which one? 17. And then 18, 22, and 31. My median, now that this is in order, my median will be that midpoint, right? That midpoint between these two halves, right? This half here, this half here. That's what the median is. Very simply put, median is that middle number when things are put, the data sets are put in order. Now it gets a little tricky when I have, because this one was easy, right? It was uneven. I can see the middle one. But if it's uneven, all you have to do, say this is my data set, right? 30, 17. We'll do the same procedure. So we arrange them, 17, 28, 30, and 31. So now it's not that clear cut. Now, where's my half, right? I want to find that middle number in that half. So all I got to do, best case scenario is, okay, the next best thing, I don't have a middle value. So let me create that middle value. So all I got to do is add the two middle ones. And whatever that is, you would divide it by, very straightforward, okay? Very straightforward. Now, whenever we have a skewed data set, what we are talking about Before I say that, any questions about the median? Okay, good. The issue is that now when we start having skewed data, right, this would be perfectly symmetrical. If this were a piece of a cake and look at that, me thinking about cake. What, would you be eating? Oh, hungry and all. Notice that this side and this side look exactly the same, but when we are having a distribution that looks like this, notice that all of my data is moving towards one direction. And if I have a data set looks like this, I also have my data moving closer to the other direction. We can really see that whenever we have the representation of the median. Now keep in mind, when we utilize the median, we have to make sure that we are utilizing an ordinal scale. Any questions about the mean or the median so far? Good deal. Let's talk about another measure of central tendency, and that is the mode. And a really good way to remember what the mode is, in Spanish, moda instead of mode, moda. Moda is like whatever is trending, right? Whatever is very typical, right? Whatever is trending, the fashion that's trending. So that's what mode is. It's whatever is repeated a lot, right? It's whatever data point we are finding over and over again, right? So if the trend, la moda, right? If moda is wearing skinny jeans, for example, then you're going to start seeing a lot of people wearing skinny jeans, right? Same concept here. The mode is that value that repeats itself, that is found most often. Right, so that's a really good way to remember what mode is what keeps repeating, what's happening more often. The good thing about something really interesting to point out is that we may have multiple modes. So for example, if I have a data set, right? So this individual scored 1, this individual scored 3, 4, and 10, 4. Notice that this will be my mode, right? This is what's in style, right? The skinny jeans. This is the one, la moda, or the mode that I keep finding over and over again. But we can have two, right? We can have two of those. So for example, instead of 4, 4, then I start seeing have 2 3s here and 2 4s here. So now we have two modes. It's maybe skinny jeans and shorts, right? Make sense? Makes sense in my little head. So hopefully it makes sense for you guys. And if it does not, please raise your hand. Right? Got our explanation. Generally, this data is not presented, it's not reported alone. Why is that? Well, because we don't want to present this data individually. We don't want you to misinterpret. So for example, sometimes you hear, oh, the average salary in America is $50,000. Does that mean that most people don't live in poverty? Does that mean that most people are not super rich in America, right? So just reporting one data set can lead to wrong interpretations, right? So I need you to remember that. All right. And when we are presenting the mode, generally on a nominal scale. Here's a good summary of the tendencies that we just covered. So notice that if, for example, this measurement was high, the distribution will look like this. This is what this interpretation means. These are the measurement scales that we will utilize for each of these measurements of central distribution. Any questions about the mean, the median, and the mode? Yes, ma'am.
You said just the mode when you said the example, you referred to it as the average. I thought the average was the mean.
Mm-hmm.
Just to clarify.
Yes.
Oh, okay.
Yeah, the average is the mean. Yes. Median is that central one when we arrange all those data sets. Right? So average, actually, the symbol for average, this is the same for me. It's the same thing.
Okay.
It's the same thing. Now, let's talk about another concept, right? When we are thinking about variability, variability sounds an awful lot to something that varies, right? That is exactly what variability means. Variability is how different, what is the dispersion? How far away are you from that mean? How far are we from that mean, right? And in keeping with our little example, of everything being distributed down the middle, what we're trying to figure out with variability is how far, right? So Peter fell here, and then Jessica fell down here, but Sarah was down here. So how far away are these data sets moving from the mean? How far away, how much distribution there is in that sense. So again, for those of you watching at home, variability is simply how far I'm moving from this average, from this mean. So if Peter is here, and Kate is here, and Sarah is here, right? How far are they? How far away are they moving from that average? Any questions about variability? Now notice that variability, again, is that spread. How far they're moving away, or how close are they to that mean? It can be anything between 0 and infinity. It could be any number. Interestingly, variability can never be negative. How so? Well, because we have these specific measurements. I'm going to cover each one in detail. Right. Let's talk about our first measure of variability. And again, when we're thinking about variability, I want you to imagine that bell. We're trying to figure out how far I'm moving, how far is my data moving from that average, from that center. Let's talk about the range. In the range, the variability that we're trying to look into is we're going to grab whichever data set or data point is the largest, and then whatever the smallest and data point is. Smallest data point is. And we're going to subtract one from the other. So the largest value minus smallest value. However, this range better fits when we don't have any outliers. Who can tell me what an outlier is? Yes, ma'am. That is correct, Dr. Countryman. Did I remember? Look at that. I deserve a lollipop. I never remember anybody's name. So if you got a lollipop, I claim it. It's mine. So Dr. Countryman over here mentions that an outlier is that measure that's an extreme. So if we keep in with our little bell, we'll clear it up for you guys. So an outlier, right? As I mentioned, measures that are here, that are closer to that average, right? Not us, we would be outliers, right? Because we're not basic. So we would be outliers, right? Basic people fall close to that central mean, that average. Outliers, as she mentioned, fall further away. So my non-basic people, right? My non-basic data sets, right? You're going to move further away from this central tendency. Think about the example that I gave you. The average person, let's say in America, the average salary is $50,000. There's billionaires in America, right? There's also people living in extreme poverty, right? Less than $1 a day to survive. So that would be considered an outlier because those data points are going to be very far away from that center, from our norm, if you will. That's why we call it a bell of normal distribution. So if we have outliers, you can see why if I grab the largest, which in this case would be a billionaire, and the smallest, which in this case would be someone in extreme poverty, you will see that that range will be pretty skewed, wouldn't it? It wouldn't actually reflect what's actually going on in that central tendency, right? This range would not really be accurate. It won't be representing that central norm idea. It's skewed. We will have our billionaires here, and we will have our persons in poverty, because these data points are pretty far from the data points that fall more in the center. Now, we have other aspects that we can look into when we are looking into the interquartile range, IQR. IQR. And with the IQR, what I'm trying to do is find the range of values between that third and that first quartile of my data. I'm going to give you an example in good old English, right? Because that sounded like a whole lot of something. So imagine in this data set that we talked about, say, for example, the persons who were millionaires versus the persons who were poor. But we're going to focus on the data that we have here. So when we're thinking about those four aspects, right? Imagine that your data is going to be divided in 4 sections. How do we know that? Well, we will find our mean. So a normal distribution, right? It will be down the middle, right? So we will have our mean and mode. Everything will fall in the middle. And then we will have over here, we will have our outliers. So here we will have our poor people. Here we have the billionaires. And then here, pretty far away from that mean. So notice this is just a representation of the same factor. And then over here, we will have our poor people. So this is our data sets. And then we will have our Q1, Q3. So this is our Q2, Q1, Q2, Q3, and Q4. So we are dividing this data in 4 sections. And we're trying to find out the data that falls between the third and the first. Basically, all that data in the middle. So all the data in the middle. So any questions about that? Any questions? Good deal. Let's talk about another measure of variability. Let's talk about another measure. And in this case, we are talking about the sample variance. Generally, sample variance will be represented as S superscript 2. Generally, this is its representation. S superscript 2. What is sample variance? There's different measurements of variance. The first one we're going to talk about is sample variance. Sample variance is simply a measure of variability, and that will be for the average square distance between the scores in a sample that is deviating from that sample mean. And in the Queen's English, what does that mean? In the Queen's English, right? So in the Queen's English, we are trying to find that sample variance. Remember, variance is, I'm trying to look out for that dispersion, right? Where are my little data points, right? If I find them here, if I find them way over here, right? So when we're talking about variance, what we're trying to say, let's find all of my samples generally fell around this general vicinity. So I'm trying to find that data that was falling a little bit further away, right? We're trying to find the distance the scores fell or deviated from that central tendency, right? So I'm trying to find that distance. How far is my data set, right? How far is this person a billionaire? How far away is this person who is very poor? How far a person that is psychopathic versus person who is Gandhi, right? So Gandhi would also be an outlier, right? The average person will be around here. Now, when we are talking about the sample variance, this is the equation for a sample variance. So we have S superscript 2, so it's going to be squared. So we're going to, first of all, we're going to have the degrees of freedom. Degrees of freedom is n, and n represents the amount of data points, the amount of participants. So if I had 37 people that participated in my study, that's my n, right? I had 37 people that participated in this psychopathy examination, for example. So my degrees of freedom is simply n minus 1. So n is simply that sample size. Now, the second portion, right, of that equation, we talk about degrees of freedom. Now let's talk about the sum of squares. The sum of square deviations from the mean. So if you remember from earlier, I had a little symbol which represents sum, and the equation to discover sum of squares going to be each data set minus that mean squared. So for example, if Billy scored 18 and the mean was, let's say Billy scored 18 and the mean for this exam was 60, and we would do 18 minus 60 squared. And we would do that for each and every set. So if we have 37 participants, that's what we have to do. We have to do this 37 times. But luckily, there's software for that. So you don't have to do that by hand, because that has to be some form of like medieval culture, wouldn't it? If you had to do that by hand. So any questions about the calculation of the sample of variance? Now, there are some advantages for us to know how far away is this variability from that mean. The advantage is that it allows for a clear interpretation. Because the larger that sample variance, the farther away those scores are from the mean, right? So for example, if I have my bell of normal distribution, I can see that if there is a great variance, so for example, my data moves all over the place, right? So I have different data points. The greater the variance, the further they're moving away, the further deviating from that average, from this average down the middle. Now, the concern with that is that the average score distance from the mean is squared, right? When we have something that is squared, our standard deviation, and we will cover that too, it's not represented in a square fashion. Okay? Our standard deviation is not represented in a square fashion, so that means that we have to conduct further calculations to find out the standard deviation. But what is standard deviation? A very easy way to look at standard deviation is that variability, that distance, right? We're looking into that distance in which we're going to take the root of this variance, right? Let me clear this up so it doesn't look like a heart attack. I'm going to calculate the root of this variance because I cannot represent it in a graph like this. So that's its limitation. Because I can't represent it in a squared fashion, I have to draw the root of that squared variation. The standard deviation is simply that distance from the mean. What do I mean by that? Let's find a good example. Let me pull one up right here. The standard deviation, notice that in this particular example, the mean, the average, right, was 20. What is my standard deviation? Usually, standard deviation is either referred to as D, or sometimes you can see this little symbol, sigma. So sometimes you can see it reflected in this fashion too. So sigma is also standard deviation. So if you don't see SD, I don't want you to, oh, wait, what? You see the symbol of sigma? See if I can draw a better one. There we go. Looks like a little O. So my standard deviation is whichever distance I am moving away from that mean. So in this sample here, notice that we have a standard deviation. So notice that in this case, this is 1 standard deviation, this is 2, and this is 3. 2 and 3. What does that mean? Means think about steps, think about milestones. So I moved 1 step further, I moved 2 steps further, I moved 3 steps further away from this mean. Think about floors in a building, right? The escalator. I moved down 1 floor, I moved down 2 floors, I moved down 3 floors. So in this specific example that we have here, notice that that standard deviation, 16 minus 40, the standard deviation is represented by 4. Right, so whenever they drew this root, the standard deviation came up to 4 with an average of 20, right? For the sake of this example, the average score was a 20. And then we would move towards 1 step further away, 2 steps further away, 3 steps further away. And the more the standard deviation, the further away we are moving from that average. Any questions about standard deviation? Right? Any questions? Good deal. Now, generally, I want you to think about, we've been talking about normal distribution. When we have data that is normally distributed, it's going to look like this. Going to look like my normal, beautiful, symmetrical bell. It looks exact. If I were to cut it down the middle like a piece of cake, it looks exactly the same on one side and looks exactly the same on the other. Here are the general rules of thumb that would apply in normally distributed data. Very simply put, I'm actually going to use different colors. So notice that within 1 standard deviation, either on the negative side or on the positive side, if I were to grab all the information that is in here, right? All of the information that is in here, that represents 68% of all of the information that is available. However, if I grab all the information within two standard deviations, whether in the negative or two standard deviations within the positive. So now I'm including all of the green plus the yellow. All of the information you've ever seen will fall two standard deviations, meaning about 95% of all that data is going to fall within these two standard deviations. Or within two steps, if you will, two floors, if you will. Now, within three standard deviations, whether in the negative or the positive, we're going to have 99.7 of all the data. We're going to have 99.7% of that data. Let me see if I can erase that really quickly. There we go. Any questions about normal distribution? So notice, the more standard deviations we are talking about, the more data is being represented. A good example that people like to use a lot is IQ, right? So the average IQ is 100. And don't quote me on this, but I think one standard deviation for IQ is 15, right? So that would be one, right? One standard deviation. Two standard deviations. Now, remember, it's 15. So this would be 115 instead of 24, and 15 again, it would be 130, right? 15 again, it would be 145. So notice that the further away we're moving from this mean here, the more people are included, but the less likely we are to find data here, because remember that the vast majority, so 68 are going to be in here, and then the rest of them are going to be here, and then the rest of them are going to be here. So notice that it's less likely, right? It's more likely that you find people who have an IQ of about 100 plus or minus 15, than you would a person with an IQ of 145, which generally that's a very gifted individual. And by the same token, if the average is 100, minus 15, minus 15, minus 15, and then we start seeing learning disabilities. Any questions about that? Good deal. Now, when we conduct our own research or lab, I don't believe I do have the data sets for them, but it's not going to happen too soon. But I do have the data sets in which we are going to conduct these assessments ourselves. Now, let's talk about graphing. Let's talk about graphing and correlations. There are different ways. And look at that, I'm in puberty. There are different ways. There are different ways in which we can graph our means. So for example, we can have a bar graph. The only thing that we are trying to do with a bar graph, first of all, it needs to be from a nominal or ordinal scale. And this is simply, we're going to represent the means with bars, right? So let me give you an example. I'm going to change this chewing gum with sleep, right? Say, for example, you have a client or a group of clients. For example, this I'm going to change to time. How many hours of sleep did they get, right? So for example, the client reports that they're oversleeping, right? Or not. So for example, they reported they're sleeping about 12 hours a day. The average for this group, and then the yes, I am oversleeping group, and the no, I'm not oversleeping group. Right, they're getting 8 to 10, which is pretty average for the normal human being. I know a lot of you don't get 8 to 10, and I'm sorry for you, but this would be the average. So notice that here, I'm only reporting on the average, because here we have the score of Peter, and Peter got a 10, and we have the score for Becky, and let's say Becky got 7 hours of sleep, and then we have, I always use Peter, don't I? And then I have Pablo, and Pablo is an 11. So notice that this is just the average. This 12 simply represents the average of all of the individuals in this regard that said, yes, I sleep. Then here it's like, no, I haven't been oversleeping. So then here we'll see that in that case, let's see, Sarah and then Kate had, let's say, 5 hours of sleep. That's pretty accurate. Hashtag relatable, right? 5 hours of sleep. But the average between all of the people that said, no, I don't sleep, falls in about a 9. So notice that a bar chart is only going to offer me the average of all of those people, right? Of all of those data sets. Interestingly, we can represent 2 factors, right? So we can represent the yes sleep, no sleep. Now, when are we looking into correlations? And here it can get a little bit more difficult. But remember, point of graphing something is to visually observe the data, right? It's not just simply a number. Now it's become a visual representation of that data set. How do we show relationships? How can I show them to you? I can utilize a scatter plot. That is simply the presentation, that graphical display of all those data points. So for instance, if you remember from earlier, right, we had our X and our Y, and X is my horizontal and Y am I jumping off this cliff. Therefore, love using that. Right, so it's going to be the vertical axis. And I'm going to summarize visually that relationship that perhaps exists between variable X and variable Y, meaning independent and dependent, right? Generally, we represent the independent variable as an X, and generally we represent the dependent variable with a Y. So for example, in keeping with our little example of sleep, right? An extensive infinity. So in keeping with our example, say we have the more stress, the more likely the person is to not sleep, right? So say we have stress, this is the independent variable of stress, and this is the dependent variable of sleep. So now we're trying to identify that relationship. So notice that here we're going to have, say, the level of stress is going to go from like 10, 15, so on and so forth. Here we're going to talk about the likelihood of not getting hours of sleep. So very likely, so 100%, and not likely at all. So you'll see how when we run the statistics and see if they're correlated, you'll notice that, say, this is Kate's score, this is Kate's and Sarah's, this is, let's say, Smith's score. And notice that these dots, this would be my perfect relationship. This represents a 1. This is a perfect relationship. The closer these dots or data sets or data points fall in this perfect relationship, the more perfect, the stronger that relationship is. Any questions about that? Good so far? Now, there are 2 types of relationships. And I know a lot of you are very familiar with this, but I do want to cover them. There's 2 types of relationship. The first one is a positive correlation. And the second one is a negative correlation. Now, when I say negative and positive, I don't want you to think, oh, it's good and the other one's bad. I don't want you to think it's plus or minus. That is not what we're talking about here. Whenever you see positive and negative correlations, I don't want you to think, oh, if it's negative, it's a bad relationship, and if it's positive, it's a good relationship. Absolutely not. That's not what this means. A positive relationship is when variable X goes up, variable Y goes up. When variable X goes down, variable Y goes down. Meaning that a positive relationship is the factors move towards the same direction. If my stress goes up, the likelihood that I'm not sleeping increases. Let's see. The more milligrams I take, or let's change that example. Let's change that example into something else. Let's see, a negative relationship. The less I do deep breathing, the less likely I am going to feel better with panic attacks. So I'm not doing deep breathing, meditating, mindfulness. That's a negative relationship. That's a positive relationship. One went down, the other one went down. The less deep breathing exercises that I do, the less likely it is that I'm going to do better with my panic attacks. But notice that it had nothing to do with whether or not one's good or bad. It's simply the relationships between X and Y, or the relationship between IB and DB. Notice that they went to the same direction. Conversely, a negative relationship is that the factors will be moving in the opposite direction from one another. The more I express, let's share the screen before I continue. The more I express my sexual needs to my partner, the more likely we are to have better intimacy. This will be an example of a positive relationship. In a negative relationship, we can think the more meditation that I conduct, the less symptoms of anxiety I would feel. That is a negative correlation. Notice that when one variable went one direction, the second variable went the opposite. In a positive relationship, we also have, in a negative sense, the less you do breathing exercises, the less likely you are to feel better about panic attacks. So notice that in this case, they both went in the same direction, meaning it's positive. Then the negative correlation means that they both go the opposite direction. Any questions about that? Good deal. Now, notice that in this example that we have here for a correlation, notice that we have that line, and this line always represents one, I should say. And if you remember from previous lectures, a relationship moves either to -1 or +1, right? Which means that no relationship, if something's not related to one another, the score will be 0. But in this case, this is a -1. It's a negative relationship. This is a positive relationship. So for instance, in this case, in the first case, we have the ratings of body image satisfaction and the amount of exercise minutes in a week. For example, if we interpret this graph, we can see that the more X, so for example, the higher the number for body satisfaction, there is a relationship between the rating of body satisfaction and the minutes that a person spends working at a gym. The greater the rating, greater the amount of time. Firstly, here we have a negative relationship. In this particular case, quiz grades, so for example, this person scored, let's say a 9, we have score grades, and this is the amount of absences. So notice that the more absences, for example, this person had 9 absences, but they got a score of a 1. So the more absences, right? More absences, the lower the quiz grade. And in this case, the higher that rating of body satisfaction, the higher the amount of time that that person reported they were working out. Any questions about that? Today, we're going to stop our lecture here. In our next lecture, we're going to talk about how to use correlation to describe reliability and other measures for correlations. Thank you for your attention.